Good morning, everyone. Myself, Altaf from C section. Today, we are going to discuss about a Z-Way based smart door lock used for protecting uh, home locks by mobile phone apps. This is my team members Shri Hari, Sharad, Amboji, and Jivan. Objectives to stimulate the functional of a Z-Way enables smart door lock, allowing users to control and monitor the lock using a Python-based simulation. A Z-Way based smart door lock is a type of electronic lock. It is a type of electronic lock that that uses the Z-Way technology for wireless communication. Z-Way is a popular wireless communication protocol used in home automation and smart home devices, allowing them to connect and interact seamlessly. If By applying the Z-Way based smart door lock, one can view the monitor the lock system through by sitting anywhere in the city through their mobiles. Next slide, my friend Sharath gonna continue.
Thank you, Altaf. And my name is Sharath from C section. And here explaining about the features of the simulation about the Zigbee control server for fast control and lock and unlock the door via simulated mobile apps commands and checks the lock status and battery level, real time battery drain simulation with the warnings. Every in a mobile app, the every log event logging with the timestamps for all actions, then multi-threading for the seamless battery simulations. Then the another functionality is about the Zigbee here, user-friendly interface, mobile app simulation interface that mimics the real start smart lock application and core functionalities about locking and unlocking actions through the app commands, then access authentication, input pin or biometric authentication, and next one is real-time feedback. Then it is enables the notifications and display the app notification for actions like locking, unlocking, and failed attempts or tempering detection or live status update. Then Z-Wave integration. In the Z-Wave integration, there is a network simulation that emulates the logs connection to a Z-Wave network and then device relaying. This demonstrates the communication through the other Z-Wave device in mesh network. And then fifth point is scheduling and automation. In the scheduling, locking or unlocking is there. Configure times for the lock automatically secure or open. Then the automation rules. Program scenarios like locking the door when no motion is detected nearby. Then last thing is security features. That security features involves the alerts. This tamper alerts triggers the simulated alerts for unauthorized access or forced entry. These are the features of the simulation about the Zigbee. And next, my friend Amboji will explaining the what are the implementation and overview. Over to you, Amboji.
Thank you, Sharath. Myself, Ambojirao GV from C section AML department. Implementation overview. A JetWave Smart Lock class simulates the Smart Locks functionality. A Smart Lock simulation is built using a class called JetWave Smart Class Lock. Methods for locking, unlocking, checking status, and logging events. This class includes method to lock, unlock, check the lock's status, and record events like usage. Battery drain simulation using a separate thread. It is also a feature to simulate battery drain, which runs in a separate thread to real-life battery usage. A command line interface simulates a mobile app for interaction. A command line interface is used to simulate how a user would interact with the lock, similarly to a mobile app. This design helps test out the smart lock work without needing a physical device, making it easier to try out features and understand its functionality. Next, Jivan, next Shriyari will continue.
Thank you, Amboji. And we have explained the code snippet. Uh, Class ZWave Smart Lock. The class ZWave Smart Lock. This line declares a class named ZWave Smart Lock. In object-oriented programming, classes are blueprints for creating objects. Instance objects encapsulate data attributes and behavior methods. In this case, the Z-Wave Smart Lock class is designed to represent a smart clock device. Next, self-locked. Self-locked true. This line defined as an attribute name locked within the class. Attributes are variables associated with an object that store data specific to the object. In this case, locked is a Boolean attribute that indicates whether the smart lock is currently locked true or unlocked false. By default, the lock is initialized as locked and self battery level is equal to 100. This line defines another attribute named battery level. It represents the current battery level of the smart lock with an initial value of 100 indicates full battery. And methods of def lock self. In this method, responsible for looking the smart lock, the implementing of this method could involve setting the locked attribute to true, sending a command to the actual Z-Wave hardware to engage the looking mechanism, logging the lock level, example, lock engaged at timestamp, potentially updating the battery level based on the clock operation. Def unlock self. This method is responsible for unlocking the smart lock. The involve setting the unlocked attribute to false, sending a command to the Z-Wave hardware to disengage the locking mechanism, logging the unlock event, example, lock disengage at timestamp, potentially updating the battery level based on the unlock operation. Def stimulate battery drain self. This method is likely intended for stimulation or testing purpose. It could stimulate the gradual decrease in battery level. Over time, the implementation evolve periodically. Example, uh, every few seconds decrementing the battery level attribute, checking for low battery condition, battery level below a certain threshold, and potentially triggering warning or alerts, potentially stimulating battery released issues like temporary unresponsiveness when the battery level drops too slow. Thank you. And next, my friend Jivan is continue.
Thank you, Sri Hari. We can how to discuss the run the script. Save the script as the Z-Wave Smart Lock. To create the Python script, save the following Python script as a Z-Wave Smart Lock. Second point, the run the script using Python 3.7 or later Python Z-Wave Smart Lock. The run the script by the Python 3.7 or later. Open the terminal or command promote and type the following command. Enter the commands and example lock, unlock on stats to interact with the lock. Lock locks the smart lock if it's unlocked. Unlock the smart lock if it's locked. Stat display the current lock status in the battery level. Exit means the exit the program. Monitoring events and battery stats in the real time. The script stimulates the periodic battery drainage. Every 30 seconds, the battery level decreases by the 1%. When the battery drops below 20%, a warning message is displayed. If the battery reaches 0%, the lock stops functionally. Unit the battery is replaced. Thank you, Anand.